I'm going to go through protocols and then we'll look at these in more detail because last week I kind of skipped over them quite quickly. And protocols are something that they could theoretically ask quite a big question on. It could be a 6-mark question. And I know I keep saying it every week, but 6 marks to a grade boundary. So it's one of those sorts of questions that you really need to try to get your head around. The same as the legal, ethical, environmental question. It's a 6-mark question. So that also can be the difference in a whole grade boundary there. Right, let's talk first of all about what a protocol is. And I guess there are two things here. First of all, a protocol has got a meaning in all sorts of different areas. So one protocol is that when you greet someone, you shake hands. Another protocol is that when you pick the phone up, you say hello. I know I'm being ridiculous, but that is a type of protocol. But what we're looking at here with computer science is protocols as sets of rules which allow devices to communicate with each other. And in particular, we're looking at the protocols that deal with data, how the data is formatted and how it's transmitted from one device to another across a network. Okay, so that's what we're looking at when it comes to protocols, and we'll look at the different types and go into them in a bit more detail. All right, so in general, a protocol is a standard way of doing things. That would get you a mark, and we'll go into that in a bit more detail. So why are protocols useful? So think about something like, I don't know, like think about the internet protocols. Everyone's internet connection works in the same way. There's a protocol used for that. Think about HTML. Think about HTTP. Think about the protocols that underpin email. Obviously, a protocol has to be the same across everyone's computer, or else the system doesn't work. So protocols literally are the backbone of the internet. Yes, you've got all the cables and wires and routers and the switches and all that kind of hardware, which is the internet. But the World Wide Web that sits on top of it, that is all about protocols and standards as well. We talked a bit about standards last week. So I'm going to really quickly cover these and then go into more detail. The first and most important one is the Internet Protocol, which is TCP/IP. It stands for Transmission Control Protocol, transmission as in sending data, and then Internet Protocol. And I'm going to talk about layers later on. But if you imagine TCP and IP are two different protocols which work together, but they both do slightly different things. I'm going to go through this in detail because while you don't need to understand packet switching in this specification, if you don't understand it, we've got 5 in. Do say hello, by the way, or don't. It doesn't matter, but as long as this is useful for you. But what I really do want you to do is if I'm saying something that makes no sense, just ask me. I'm literally here to help you, okay? Right, Transmission Control Protocol, Internet Protocol. These two sets of rules work together to transmit data across the internet. So let me tell you a story about how that happens. So this is how, for example, you are sending any kind of data across the internet. The first thing is that TCP, Transmission Control Protocol, that is to do with the transmission of data packets. So if, for example, you are sending any data across the internet, rather than being sent in one big chunk, it's actually split up into packets, little tiny packets of data. And these packets have got headers which say what they contain, and they're given a packet number. So, for example, if you're sending an image, it might be split into 100 packets. Let's make it an even number, and it'll be packet 1 of 100, packet 2 of 100, and so on. Do you understand? So these packets are sent across the internet. And that piece of hardware we covered last week, the one that OCR love to put into their exams, in other words, routers, which is responsible for this job, your packets of data may go through a number of different routers before they get to their final destination. So there's a bit of addressing that has to happen here, because if you're sending somebody something over the internet, you have to have an address you're sending it to. Think about the postal service. It's the same deal. Packets have to have a destination address, but you also need the address they're coming from, or else if it goes wrong, you can't tell them that it hasn't been sent, so it can't be sent again, okay? So the way it works is this. First of all, the data are split into packets, and then the packets are addressed, and then the packets are sent, and it uses IP addresses to get there. It might go through 5, 6, 1 routers, and the router will decide what the best next direction is, where to send it, okay? What the next router to send it to would be. When it gets there, it puts the packets back together, that's that one there, and then the error check makes sure that what was sent is what has arrived. And there's a clever bit of math that does that. It's an algorithm. We don't need to worry about it too much. But for example, if 50 KB is sent, that 50 KB has arrived. That's the idea. Now, that's useful because we can't really talk about layers and protocols unless you know in detail what this protocol does. So TCP/IP, they sit there in layers, one on top of the other, and one hands over to the other, which does a bit of a job, and then it hands back. So these two work in that they cooperate with each other, but they're on different layers, and we'll get to that later on. So that is, and we've got IP addresses, which is the addressing of packets, the Internet Protocol. Okay, so TCP/IP. So the IP part is the Internet Protocol that's got to do with addressing. So we know that a web address or a URL, so bbc.co.uk/news is a URL, a Uniform Resource Locator. That's what it's called. That's what we type in. And then sitting behind that, there's an IP address, which is a series of numbers, 192.6.5.24. Okay, so that is how it works. It's a bit complicated. Go through it a couple of times because the story does, oddly enough, make sense, and it's quite pleasing to actually work out how to actually understand how these things work. I think that's what makes us a bit different to most people, computer scientists, is that we're quite curious about knowing how stuff works. So that's the first protocol. All right, we've looked at TCP/IP, and that's to do with sending data. I mean, all of these are related to data, but they're all slightly different. This next one, you'll recognize HTTP and HTTPS. So this is a hypertext transfer protocol, and this is used to transfer web pages over the internet. And again, the protocol, look at what it does. It defines the format of data. Okay, that's what it does. It's about how data is formatted. It's a set of rules for how it's formatted. Okay, the only difference between HTTP and HTTPS is that HTTPS is secure because it's encrypted. And if you remember from my from last week, I tried to force you to learn it turns plain text into ciphertext. That's the magic phrase you need to learn to make sure that if they ask you anything about what's encryption, it turns plain text into ciphertext. And the next part is so that if the data is intercepted, it is unintelligible. So, for example, if a man-in-the-middle attack occurs where you send something across a wireless network to someone else and some hacker has got packet-sniffing software to pick up your packets of data, if you've encrypted your data, they can have your data, but they can't read it because it has been scrambled, it's been encrypted, and they need your private key to do it, and they can't do it. I mean, they could do it, but it would take hundreds and hundreds and hundreds, possibly even thousands of hours to do, by which time it's probably useless, and they're unlikely to try, really. So a couple of things there. HTTP, HTTPS. Probably the only thing that you need to know here is that this has got to do with web pages being sent over the internet. They love to do a bit of a table on for this one to make sure you understand what the different protocols are. Right, FTP. This is why I'm going to these in a little bit more detail. FTP, imagine the scenario where you are making a website. And we know that a website consists of text, images, maybe some video files, some audio files, that sort of thing, right? It's basically a document with some resources inside it, isn't it? So FTP, File Transfer Protocol, it's a very simple application, and it works on a protocol that allows you to take one file and to move it somewhere else. So any sort of data to move it from one place to another. So if you're building a website, you might build the website at home on your home computer, and then you will end up with the web pages and all of the resources that you want to upload to it, the images, the videos, etc. Okay, you then can upload all of those to the web server. Again, going back to last week, a lot of things linking together now. You'd upload that to your web server, who your hosting company, who will be hosting it on a web server, and you can upload it really easily. And that's the way you do it. That is how you get and you upload data onto a website. So that is your FTP. It can also be used to share files. It's a really simple interface. It's a window that's split in half, and one is your home computer, and the other half of the screen is where you're sending it to. And you simply drag and drop and let go, and it'll end up being in the place that you've defined on the right-hand side. So that is FTP. I'm going to go into a bit more detail on these, but POP, IMAP, and SMTP are all email protocols, two for receiving and one for sending. So when you receive emails, you're either using POP, the Post Office Protocol, or you're using IMAP, the Internet Message Access Protocol. They both do a similar thing, but they do it in a different way. The Post Office Protocol is slightly older, and I'll go into more details on that in a second. And IMAP has it's got additional functionality, which is why it's kind of the go-to protocol, really. And then you've got SMTP, the Simple Mail Transfer Protocol, which is about sending emails. All right, so these are the protocols used by your by your mail servers to send and retrieve emails. I put this in there, I think I did this one last week, is that the definition of communications protocols is that they're sets of rules for transferring data. That's slightly simpler than what I said earlier for how data is transmitted, right? So that is your communication protocols. So these definitions, the ones I put in gigantic yellow post-it notes, it's even hurting my eyes, these are the ones that I recommend you go away and learn, because I've pinched those from mark schemes, and they turn up with dull regularity every year. The exams are honestly quite similar every year. A lot of students reported to me last year, in the school where I teach, on exam results day last year and year before, I interviewed the students picking up their exam results and asked them what was the most important part of your revision, what helped the most. About half of them said past papers. So pester Mr. Vladdy Godfrey for past papers, because he can give you as many as you need and just work through them. And if you're one of those students who's really struggling with the coding aspect, you find writing algorithms hard, I promise you, if you can work your way through one or two of those a night, you'll get to night 5 or 6 and you'll think, hang on, this is exactly the same. They're only asking for 3 things. It really is quite formulaic, but it is quite an abstract thing to understand. So I know people struggle with it. Right, in front of you. Now, I'm very proud of this, so I think we should do a round of applause for my amazing work here. I'm hoping you figured this one out ahead of me. I think I mentioned it last week. We've got the 6 protocols that you need to know here. And I'm very big on having easy ways of remembering things, because even though I teach this subject, learning to remember things like SMTP, IMAP, HTTP, FTP, it's difficult because they're just letters thrown together, and it's not that easy. So you could, inside your mind palaces, I'm quite big on these, that you could build a situation in which you place these 6 objects in a room, and that might take you to remembering what these different protocols are. So obviously over here I have got SMTP, a TP, do you get it, TP? I was very proud of that. Over here you've got, well, I needn't tell you, an I and a map. And again, if you go inside your head, you pick a room at school or a room in your house at home, and you simply place these items in there. That's what I get my students to do, and actually it tends to work. People only don't do it because they think, well, it takes too long. But it's it's a more efficient way of remembering things than just staring at a piece of paper and going, IMAP, 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 because you won't remember it because it's boring. All right, so over here we have got HTT, see the T, the golf T? I was very proud of this, and P. None of my students understood that one. Over here, this one is obvious. It is POP, as in popcorn, 3. POP is the one that you need to know. And then this one is, what is this one? Oh yeah, TCC. I've forgotten myself. This one is TC's T, come here. T as in a pot of tea. There we go, where's my arrow? T, C as in glasses. Although I'm not sure how much you can see with glasses that thick, and the letter P, TCP, so Transmission Control Protocol, which we've just covered, TCP/IP. So that I'm hoping will enable you to remember these a little bit more easily, because I don't envy you. You've got a lot of quite dry facts to learn. So make it easy on yourself. And yes, it takes a bit longer initially to commit these to memory with a daft sort of system like this, but I promise you it works. I did something like this with my Year 11 students for system threats. We created a house of horror and put all of our, and you'll see that when I go through that with you in time. And the results were a third better. They were 30% up. So it really does work, because sitting down and just learning these is really difficult. Right. I promised you details, so let's do detail on these. We're looking at TCP/IP, which I mentioned before, which relates to packet sniffing, and we know that it stands for Transmission Control Protocol, Internet Protocol. It specifies how data is transferred from one device to another. There's a mark for you there. The two of those are separate protocols, as I mentioned earlier, and this is how it works. IP obtains the destination address for the data being sent, and the TCP is responsible for the delivery once the IP address has been found. The message is broken into packets, and that's we talked about the packets earlier. And think about the success of the internet, and it's TCP/IP that has made the internet so successful. I won't go into the long, boring story of why we've reached this point, but it's not boring, which is that America in the 60s was so paranoid about their communications hubs being blown up that they actually created a system that even if cities were taken out, they could still relay messages. So that's where this comes from. It was a military application in the first place. It's called the ARPANET. So then the messages are reassembled at the other end, and each packet could take a different route. As I said to you, the stuff about packet switching isn't in the exam any longer. But without knowing that, the TCP/IP kind of doesn't make any sense at all. So that's why I've put it in there. We have got 10 people in. Well done, guys. Well done for being here on a Thursday night at 6:20. All right, let's jump in and look at HTTP. It stands for the Hypertext Transfer Protocol, HTTP, and it's used for the World Wide Web. And you can see I have put the words important there. So if you want to get yourself a grade up to a grade 6, that's probably all that you need to worry about, okay? It also follows the client-server model, which we talked about earlier. Do you remember the client-server? This was a sort of type of network that you could have where you had the client, which just gets the information, and the server, which is a big, powerful computer with lots of attached storage, which serves up the information to the client. As opposed to a peer-to-peer network, if you remember, which is when all the nodes or computers are equal and you are simply connecting them, plugging them into each other. All right? So it's an application layer protocol. Forget that for the time being, because I'll come back to that later on. So the web browser, which is the client, communicates with the web server, and the web browser is on your computer. You are the client, and you are communicating with the web server, which serves you up your web pages. It's a communication designed to deliver HTML files. And it's worth just going a little bit deeper here and saying that every web page is actually an HTML file. It's a file type, and that's the sort of the language in which web pages are written, is hypertext markup language, okay? And HTTPS, we said, is encrypted. And I won't make you repeat turning plain text into ciphertext again. I really hope it turns up, because I've said it so many times to my classes. Okay, FTP. I covered FTP. If you, for example, wanted to upload the contents of a website, images, web pages, text, etc., you would use FTP. CyberDuck is a free one that works very well, and web authoring tools like Dreamweaver have got a built-in FTP client, all right? It's an app, effectively. So it stands for File Transfer Protocol, and all that you need to know, again, looking at my important stamp there, which I was very pleased to find, it allows files to be transferred between any two nodes using the protocol. So where I've written important, that's the stuff that you need to learn off by heart for the exam, okay? We've got 11 people in. Well done, guys. Okay, so that's FTP. It's a foot I've got there. I understand a foot is not, it's the closest thing I could think of. But feet, FTP, it's close, isn't it? I mean, give me a break. It's not that easy to think of these things sometimes. We've got SMTP, TP, I anyway, let's not go there. SMTP is a simple mail transfer protocol, and it's a push protocol used to send email. You don't need to know it's a push protocol, but it is. This sits on the application layer. Just file that away slightly somewhere in your head, my reference to it's on this layer or that layer, and it'll make sense to you in a couple of minutes' time. So the way that this works is the client, you, opens a connection to the SMTP server. That's the first thing, okay? Get off. Why has it gone that weird colour? Stop. Come on. There we go. Okay. So the SMTP server is always on and in listening mode, and the connection's through port 25, and the email's sent immediately. So this detail down here, you don't really need it, but I've put it there because just teaching random facts without context kind of doesn't help. That is how it works. And students often report back to me that it's these extra details that actually help it sit inside your head, because then it makes sense. You understand what this protocol does. So SMTP, it's for sending email. That's really what you need there, okay? All right. So that is SMTP. How are we doing time-wise? 25 past. Yeah, we're pretty much on track. Then we've got IMAP. So IMAP has certain advantages over POP. So IMAP and POP do the same thing, but in a different way. So you will use, let's just go back one step, right? You have your phone and you turn your phone on and you want to look at your email messages. But at the moment, your email messages are sat on the email server. You open your email client, Outlook or Hotmail or whatever you're using, and that application on your phone or on your laptop, whatever it is, communicates with the web server, and it downloads your messages. And the protocol, the set of rules for downloading messages, is either POP or IMAP. So this is getting emails from a web server. Now you've got a choice of POP or you've got a choice of IMAP. Now I fancy that they might do. I keep doing a bit of question spotting. Sometimes I'm right, sometimes I'm wrong. But they haven't done anything big on this for a while, and I reckon they might try and get you, this would be at grade 6, grade 7 perhaps, to try and pull out the differences between them. So I'll run through what they do, and then I'll talk about what the similarities and differences are. Well, the similarities are easy. They're both for downloading mail messages from a mail server. So IMAP stands for Internet Message Access Protocol. Again, the layer thing is on the application layer, and it's used, the important one is it's used to receive emails from the mail server. And if they do ask you, put in that level of detail, because that way you know you'll get the mark, okay? Again, it follows the client-server model. So it's not peer-to-peer, it's client-server. These things, they're all knitting together, aren't they? This is what we were talking about last week. So the way it works is the IMAP client, so that would be you accessing your emails, have the process running, while the IMAP server, which is in cyberspace somewhere, runs the same process. And both the computers connect. They do what's called a handshake. That's the name it's actually given. So the difference is that with POP, unlike POP, with IMAP, the users may access mail from the remote server. This is the difference, while retaining the mail in the remote server. So here's the thing. With POP, it's an old-fashioned protocol. If, for example, you downloaded the email messages that you had onto your phone, and then you went onto your computer and went to access your email, it wouldn't be there because you would have downloaded the email from the phone. I'll try that again. You would have already downloaded the email from the server. So it's literally a one-hit thing that whenever you first access the server, you download your messages and they're not on the server anymore, which isn't great. POP was fine when everyone had one computer back in the 80s and 90s. But now that everyone, I mean, count up how many devices you've got that can read email. I mean, I've got this computer here, I've got a laptop over there, I've got my school computer, I've got a phone, I mean, I've got an iPad, and on and on and on and on. So what IMAP allows is for you to track messages, okay? In other words, so if you think about it, when you download a message and you look at it, the message gets grayed out. So therefore, if you go and look at the same message on a different device, the message is still grayed out. So it's that synchronization that is supported within IMAP that isn't there within POP3. 6 people in, well done, guys. I know it's a bit technical, but that is literally the only difference that you need to recognize in the exam, okay? So what's the benefit? It means you can manage multiple mailboxes and transfer messages from one to another. So IMAP became really useful. It had to be developed because people had more than one device, and therefore POP didn't really do it anymore. Okay, so that's POP and that is IMAP. And you can see now why I went back to this, because there's quite a lot of technical data involved here. This is POP, and this won't take very long. It's called the Post Office Protocol, and it provides a mechanism for retrieving emails from a remote server. Okay. Notice again, it's an application layer protocol, sits on the same layer as the other mail protocols we've just discussed. And here's the difference in important. Once the emails are downloaded from the mail server, they are deleted from the email server forever. Well, forever is a bit dramatic, but it's true. They're just deleted. They're not there anymore. And again, this bottom point here says exactly the same thing, doesn't it? The email is only accessible on the computer that downloaded them. So these two mean exactly the same thing. But I have a feeling that they're going to ask you to work out the difference between them. So again, I think that's something they might do. But they usually ask quite a number of questions on this topic. They won't necessarily cover every topic. They usually do in some way, but there'll be some in more detail than others. But they love this topic because it's technical, and also they can write a story, the story of DNS, and then they can get you to fill in the gaps. So make sure you go back and look at that DNS and you're happy about what a URL is, what an IP address is, what DNS does, which converts the URL bbc.co.uk/news into the IP address 192.6.4.8, okay? And then don't forget the domain name. An example would be bbc.co.uk, nike.com. So it's the top level domain, and it's from there that you access all of the other resources by adding additional pages, okay? News resources about us, all that sort of stuff. So you add additional pages to it. All right, so that is your POP protocol. I've got to warn you, things get a little bit harder now, the concept of layers. What's difficult is that I'm about to confuse you even further. So layers, it's a concept, but it's not real. But it is real. If you're still there, I'll carry on talking. So if you think about the internet, you think about computers, there are lots and lots of these different sets of protocols that have to be written. The problem is, if they all sit together on the same layer, it means that if you change one thing, if one part of it changes, other parts might not work. So therefore, computer science very ingeniously has worked out this concept of layers, that each of these protocols and each layer deals with different parts of the process, okay? So this, by the way, these points here, again, are taken from mark schemes. I can claim no credit for these, but this is, I did a phrase frequency check on these. This is what turns up every single time. So even if you closed your eyes on a question in layers and you wrote down all these things, chances are you might get at least a mark. This is the way it works. It splits a network, and we're looking at networks, aren't we? It splits a network into separate layers. And on each of those layers, each layer performs a different function, okay? And then each layer is an abstraction of networking. They've taken networking and they've broken it down into different stages, different layers, different areas. And the protocols all sit on different layers. And the bonus here is that you can ignore layers that are not relevant. Warning, I'm going to talk about this a bit more. But if you don't want to listen, just go and learn what's on that page, or at least learn two of those. So when it talks about what are layers, you can say, well, layers, it's about splitting the network into separate layers. Or you can say each layer performs separate network function, okay? Any of those will get you marks. Right, so I'll go in and do a little bit more on this. This is now, I'm kind of heading at the grade 5, 6, 7 plus area here. We've still got 7 people here, which is good. Layers, it's a division of network functionality. I mentioned that. It divides programming activities into separate functions. So, and this is actually probably a better way of describing it, that the activities that you might do on a network or that a computer does on a network, they're all divided into separate layers. So activities and certain activities sit on one layer, different activities sit on another. And these are organized hierarchically. Example of a hierarchy is a school where you've got a head teacher, you've got 2 deputy heads, you've got a couple of assistant heads, and then you've got middle management like me, a head of year, and then you've got your teachers. Yep. So that's sort of hierarchy you've got there. Now, this is the key bit. This is why there was this big build-up, is that each layer only communicates with the layer directly above or below it. And do you remember TCP/IP when we were talking about packet switching and sending packets across a network? Those are two protocols on 2 layers which are on top of each other, and one hands off to the other and then hands back. So that's what's so clever about these layers, is that they are able to talk to only the layers above and below them. And we'll look in a second why that is such a clever thing. Almost there, actually. I've got about another maybe 10 minutes to go. Right, benefits of layering. So if you imagine that all of these layers are on different areas, and let me just go forward a few slides so I can show you what this looks like. That's quite complicated. Do I want that one? Have I got a simpler one? You can see where we're going in the future. Hang on a second. I think I might have. Yeah, there we go. This is what you need to understand. So each of these, see, now you should remember we had the application layer. This refers to this. The transport layer is this. The internet layer is this. And the network interface layer is this. So there are different activities happening on each of these different layers. I'm going to jump back in time and go back to where I was and then get through these. And then I can leave you to enjoy your Thursday evening before we go and do a whole... I did that one. Before we go and do a whole Friday. Right, benefits. A layer can be removed or changed without affecting other layers. And that is why it's such a powerful way of organizing networking. Because you can change one layer, and as long as the changes you make work with the layer above and below it, the whole thing works well. Otherwise, you've got the grim reality of someone changing something in TCP, and suddenly every single other protocol in networking needs to be rewritten. But as long as it works with the layer above and below it, see how clever it is? Then everyone's happy. So each layer is self-contained, so it can be programmed individually. So you have experts who are working on these different layers, and that's what they do, because these layers are being sort of constantly updated and improved, as new devices come out, as new discoveries are made, as bandwidth increases, and as people's needs change. So different layers interface with different hardware. Each layer has its own jobs attached to it, activities that are done on that layer. And by doing this, it means that individual protocols are much smaller. Otherwise, you'd have to write a protocol, one protocol, which dealt with web pages, dealt with email, dealt with packet switching, and dealt with file transfer protocol, uploading and downloading files, which is a massive pain in the neck, so you simply wouldn't do that. And this means that different developers can concentrate, that's that end word there, on one aspect of the network. And it promotes interoperability, which means that systems will work between vendors like Philips and Samsung, or Apple and Mac. Not that Apple and Mac like things to work on each other's systems. They often try hard not to, but that's not the point here, because obviously they're rivals. But that is the benefit of layers. Usually up to about 4 marks on layers, so worth digging in and making sure you're happy with really definition of layers and the benefits of layers. That's really where you should spend your time. Right, I did save this to the end because I wasn't sure that you'd still be here by this point, because this is where things get... This is far, far, far more information than you need, but I wouldn't be doing my job if I didn't explain to you what this is. So there are more layers than 4, but for the GCSE, they carve out a certain amount of information that you need to know. So you need to know the TCP/IP 4-layer model, which has got the network layer, the application layer, the internet layer, and the transport layer. Now, it's not my intention to go through every single one of these because life is far too short, but do just look over here and have and understand that these layers do entirely different jobs. Let's start with this one over here, the network access layer. Now, this is the first and lowest layers, and this is literally only dealing with how the physical transmission of data. So we're talking about, this is cables. So how data's moved through cables. This is this particular protocol. So cables, repeaters, hubs, switches. So all of those devices, they sit on this particular layer, which means that if something new happens, if a new type of repeater or hub or switch comes out, then you will need to change this layer only. The internet layer, which is layer 2, which sits on top of it, as long as what you've done to this layer 1 doesn't impact on the internet layer, these two, 3 and 4 down here, they'll be absolutely fine because they don't talk to, these two here don't talk to this one, okay? So that's really important. They only talk to, it's not talk to, but communicate with the layer above and below it. So this network layer is about the physical connections between devices, okay? We don't see any of this. It's about data being moved in binary, in packets and in frames, okay? And it's got to do with the Ethernet protocol. So literally data moving through cables. Then we go to the internet layer. And the internet layer is, of course, part of TCP IP. That's the IP part of it. It's the second layer, and this is all about addressing. So making sure that packets are sent to the right place, making sure that packets are sent in the right direction. And this is where routers are used. So routers sit on this layer here, and you've got cables, bridges, and all that sort of, all these. So you've got devices that will work on these different layers, okay? It's to do with error handling, packets, protocols, etc. Okay, then we've got the transport layer down here, and this is for communication between hosts. Okay, protocols TCP and UDP. So you've got TCP here. Let me just get out of there. You've got TCP, which we've talked about, and you've got IP. So you've got Internet Protocol, which sits on the Internet layer, and you've got TCP, Transmission Control Protocol, which works on the transport layer. So these two hand off to each other, all right? So the IP is doing the routing, and the TCP is working on the data actually being transmitted, okay, and chopping the message into, it doesn't chop it, it just puts it into packets, okay? And then lastly, you've got the application layer over here. I'm only going to say one more thing about this, I promise. There are still people watching this, which is well done. The application layer is the fourth layer. Something else worth remembering is that the higher the higher the layer, the higher the level of the layer, the closer it is to what we humans are actually doing. So on this layer, the fourth one, this is where your web browsers work. So if you're using Chrome or you're using Edge or whatever, this works on the application layer. So this layer is responsible for presenting data to the user. FTP, HTTP, remember all of those? They all sit on this layer. I hope that makes sense, but the idea that this is a very clever architecture, and it is an architecture, it's a way of having a network for transmitting and receiving data, and everything sits within this model. There are actually about 7 or 8 layers, but let's not get into that. You don't need to worry about that too much. So that is where we are. Well done, guys. You are still here. 7 people in. I've actually been through this, so we don't need that. A bit more detail. I will send I think I've given Mr. Villani Godfrey this. If not, I will send it to him. And again, you don't need all of the details on here, but that is the sort of thing that you should be concerning yourself with. And this again is my last slide today. So I'm going to finish at 1:45 today, unless any of you have got any questions or you desperately want me to teach you some more. So there are your 4 layers. And I'm hoping that you've grasped this idea that layers on each layer, you've got different activities happening that happen on a network, and you could say that on each layer you've got different hardware that works, different devices that work, and those devices, the rules that are written for how those devices communicate with each other, those are the protocols, and they each sit on a layer. And it's so clever because if something is happening on the application layer, as long as it works on the transport layer, these two don't matter at all. Okay, so these are just irrelevant because these two here will talk to each other. This one will talk to this one, and this one will talk to this one. Okay, I don't want to sort of over egg the pudding, but that's kind of where we are here. Have any of you got any burning questions? I've said 45 minutes and I've done 45 minutes. So I'm not going to do any quizzing because it'll be me quizzing myself, which isn't a problem. And I've sent Mr. Valley Godfrey all of the cards to test yourself. What are they called? The flashcards. Have a go at those and just sort of do 5-10 minute bursts of those. They are incredibly useful. Guys, it's been a massive pleasure. I won't see you. I won't see you next week because it's your parents' evening, but I will see you the week after. Good luck, and I'll see you in 2 weeks' time. Bye bye.